Top 5 China's mega projects that left U.S. engineers in total shock. This isn't sci-fi, it's not 2050, it's happening now. While many countries face aging infrastructure to fix century-old bridges, across the Pacific, another nation is quietly redefining the limits of engineering. And no, it's not in Silicon Valley. In China, what was once deemed impossible is becoming reality. High-speed trains piercing the Himalayas, hydropower plants deep enough to swallow skyscrapers, sea-crossing bridges built with sub-5 mm precision amid typhoon-prone zones, and airports larger than 100 football fields rising from farmland in just years. These aren't just projects, they're strategy, speed, a revolution in infrastructure, executed with sub-millimeter precision. Traditionally, the U.S. was seen as a leader of infrastructure, the Golden Gate Bridge, Hoover Dam, the interstate highway system. But in 2025, a new leader has emerged, not just with technology, but with national-scale ambition and clear developmental goals. Join Top 10 Discoveries Official as we explore 5 of China's mega infrastructure projects, not only stunning global engineers, but reshaping how nations connect and grow. Toronto Top 5, high-speed rail on the roof of the world, Sichuan-Tibet Railway. Among the boldest projects Western engineers have seen, the Sichuan-Tibet Railway epitomizes pushing engineering boundaries. Linking Chengdu, Sichuan's industrial and tech hub, with Lhasa, Tibet's highland capital, this railway opens a transport corridor through the Himalayas, once thought untouchable for high-speed rail. Spanning 1,629 kilometers, approximately 95% of the route is bridges and tunnels through mountains. The 435-kilometer Ningqi-Lhasa section, operational since 2021, is the world's highest electrified railway, with stretches above 5,000 meters. It crosses over 40 geological fault lines in one of Earth's most active terrains, requiring bridges and tunnels designed to withstand massive tremors in extreme weather. In these icy, low-oxygen highlands, Chinese engineers implemented specialized solutions: heated tracks, real-time seismic sensors, and trains with automated oxygen cabins, maintaining 23.6% oxygen levels for passenger health. This isn't just a railway, it's a live engineering lab at deadly altitudes. A standout feat is the 42.4-kilometer Yigong Tunnel, carved through complex strata with geothermal temperatures up to 89 degrees Celsius, where standard drilling machines couldn't operate continuously. Such tunnels demanded advanced tech and cooling systems for equipment and workers. What sets this apart globally? Compare it to the U.S. California's high-speed rail, HSR, announced in 2008, remains incomplete in its first phase, with costs ballooning past $100 billion, triple initial estimates. Meanwhile, China operationalized 2 of 3 Sichuan-Tibet segments in a decade, despite terrain far more complex than California's Central Valley. The gap isn't just labor costs or policy models, it's integrated execution, hundreds of contractors, research institutes, and logistics systems working as one. Beyond engineering, the railway connects Tibet, an isolated region, to China's modern transport grid. The Ningqi section, near Tibet's southeast border, cuts passenger and cargo transit from days on mountain roads to hours. Commercially, it can move 10 million tons of goods yearly, unlocking logistics and tourism potential in China's western provinces, where infrastructure lags. Areas like Gyeongsang, near Nepal's border, gain cross-border supply chain links via branch lines, reducing reliance on roads. At over 3,500 meters, amid harsh climates, lurking quakes, and scarce oxygen, Fuxing CR200J trains speeding through the Himalayas embody China's infrastructure tech prowess. Top 4, Pingtang Bridge, the bridge floating in the sky. In Guizhou's rugged limestone mountains, once among China's least accessible regions, a structure rises above the clouds, taller than the Eiffel Tower. The Pingtang Bridge, with its 332-meter main pylon, is among the world's tallest bridges. Started in April 2016 and completed by December 2019, it's not just a height marvel, but a symbol of comprehensive infrastructure strategy, tied to poverty alleviation in one of China's most underserved regions. The entire structure is designed as a three-tower cable-stayed bridge spanning the Kaiodu River Valley, an area with complex geological features, including steep cliffs and a deep ravine. Thanks to this special design, the bridge can withstand enormous loads while maintaining stability against strong winds and frequent storms in the region. The construction technology of the Pingtang Bridge also reflects a significant level of advancement. Composite steel concrete girders, a deck width exceeding 30 meters, and an integrated wind-induced vibration control system used during the building process. Some components were prefabricated off-site and then assembled on location to accelerate construction and minimize labor risks. However, the claimed prefabrication rate of up to 90% has not been officially confirmed. The total construction cost of the bridge was approximately 1.5 billion yuan, around 215 million USD, a remarkably impressive figure given the scale of the project. Unlike urban centerpiece bridges in big cities, Pingtang wasn't built for flash. It tackles infrastructure isolation. Guizhou, a mountainous province home to ethnic minorities like the Hmong, was long cut off by terrain, making travel arduous. Before Pingtang to Lodian trips took over 2.5 hours. Now it's just 1 hour, opening trade, tourism, and labor mobility. The bridge also weaves in local culture. A service area hosts a museum, hotel, and Hmong cultural performance space, blending engineering with heritage. In the U.S., bridges abound, but a worrying stat stands out. Over 30% of U.S. bridges have exceeded their 50-year design life. In states like Idaho, it's over 50%. While 2025 data isn't finalized, AC reports U.S. bridges are aging rapidly, needing $125 billion for upgrades over the next decade. Meanwhile, Guizhou alone built nearly 30,000 bridges since the 1970s, an unprecedented push to link mountains to progress. Pingtang shows infrastructure isn't just economic, it's a long-term social strategy. Globally, it proves a nation can use engineering and connectivity to reshape development maps. If you're in the US, seeing Pingtang rise above the clouds, you might ask, why are we stuck with overdue bridges, unrepaired since the 70s? That's not just a technical question, it's a societal challenge for growth. Top 3, Baihetan, the mega hydropower redefining energy. Between Sichuan and Yunnan's rugged cliffs, where the Jinsha River carves through mountains, China built a colossal project not just generating power, but signaling a new era in engineering ambition. Speed, scale, and strategy are reshaping clean energy. The Baihetan hydropower station, the world's second largest after Three Gorges, boasts a 16 gigawatt capacity, over 7 times that of the US's Hoover Dam, 2.08 gigawatts. Its most jaw-dropping feature lies underground, a 217-kilometer tunnel network equivalent to New York to Philadelphia. These tunnels guide water, control floods, store energy, and power generators. Inside the mountains, 16 Francis turbines, each 1 gigawatt, the world's largest, weigh over 2,100 tons, with 4-meter-high shafts and 16.2-meter diameters. These stats sound dry until you realize one turbine spin could power a small nation. The underground powerhouse's central chamber, 438 meters long and 88.7 meters high, could span a volume comparable to major aircraft hangars end-to-end. An industrial cavern where engineering meets geology. On the surface, Baihetan's 289-meter double-curved arch dam, one of the toughest to build, directs water pressure to mountain flanks, saving materials and boosting durability. It can discharge floods at 42,346 cubic meters per second, 17 Olympic pools per second. Its reservoir holds 20.627 billion cubic meters, regulating up to 10.43 billion cubic meters, enough for Texas's annual domestic water use. Baihetan's annual output of 62.443 billion kilowatt-hours powers approximately 50 million Chinese households. Replacing coal, it saves 20 million tons of coal and cuts over 52 million tons of CO2 yearly. This isn't just engineering, it's key to China's carbon peak by 2030 pledge, a clear international commitment. Compared to Hoover Dam, completed in 1936, a historic marvel but now more symbol than strategy. At 2.08 gigawatts, it generates approximately 4 terawatt-hours yearly, just 6% of Baihetan's output. The U.S. debates renewable energy policy, tangled in multi-level governance, environmental rules, and land compensation costs, with no million-kilowatt hydropower approved in 2 decades. China finished Baihetan in 5 years, a pace most developed nations need a decade to match. Baihetan doesn't just generate power, it created over 50,000 jobs, boosted southwest China's lagging regions, controls floods, improves river navigation, and integrates into the world's largest clean energy corridor with Wudongde, Xiluodu, and Three Gorges, totaling over 300 billion kilowatt-hours yearly. If the U.S. used Hoover Dam as a Depression-era recovery icon, Baihetan is a green recovery symbol, not just for China, but a world grappling with climate and energy. Top 2. Daxing, the Starfish Airport redefining infrastructure. Speed. Imagine an airport the size of 100 football fields where every passenger reaches their gate in under 8 minutes. No internal trains, no shuttle buses, just speed, efficiency, and optimized design, all converging at one point. Beijing Daxing International Airport, PKX. Opened in September 2019, just 5 years after breaking ground, Daxing isn't just a massive transport hub, it's a symbol of modernization and high-efficiency project delivery, a pace many developed nations struggle to match. Its 700,000 square meter terminal is among the world's largest. The 5-wing Starfish design by Zaha Hadid architects minimizes walking. From any terminal point, passengers reach the farthest gate in under 8 minutes. Spanning 2,679 hectares, it has 4 civilian runways and 1 military, set to handle 72 million passengers annually by 2025, which is 200,000 daily. Long-term plans aim for 100 million by 2040, making Daxing a top global transit hub. While Western airports grapple with congestion, Daxing embraces full-tech integration, facial recognition for check-in, security, and boarding, automated baggage with RFID for real-time tracking, minimizing losses, 5G coverage for ultra-fast networks for passengers and operations, smart robots guide passengers, provide flight information, and assist those with disabilities. Energy smart climate control cuts CO2 and power use, meeting global green standards. When Daxing finished in 5 years, New York's LaGuardia Airport, a key U.S. aviation hub, was still slogging through a near-decade-long upgrade. LaGuardia. Terminal B and C upgrades, 2013 to 2022, cost approximately $8 billion. Daxing. Built entire terminal, infrastructure, and transport links in 5 years, 2014 to 2019, for approximately $11.5 billion, more efficient in scale, capacity, and tech. It's not just time or cost, but vision. Daxing syncs with highways, subways, and national high-speed rail, making it a strategic logistics core south of Beijing. Opened before the 2022 Winter Olympics, Daxing became a symbol of international coordination and efficiency, showcasing China's organizational and connectivity prowess. Beyond Beijing, it links the Beijing-Tianjin-Hebei Triangle, a region eyed as a megacity of over 100 million. In the future, Daxing could tie into transcontinental transport, from the Belt and Road Initiative, BRI, to Central Asia-Europe economic corridors. Daxing isn't just an airport, it's a lesson in integrated planning, modern management, and long-term strategy, showing China's national infrastructure speed, has drawn attention from infrastructure planners worldwide. Top 1. HZMB, the $15 billion bridge linking China's future. It's not an ordinary bridge. It's a 55-kilometer bridge tunnel complex crossing seas, diving under oceans, connecting 3 cities with distinct legal systems, built with sub-5 mm precision. The Hong Kong-Zhuhai-Macau Bridge, HZMB, is among China's most ambitious projects. It slashes Hong Kong-Zhuhai travel from over 4 hours to 40 minutes. It's not just the world's longest sea-crossing bridge. It's a physical emblem of China's 21st century infrastructure speed, capacity, and developmental ambition. The 55-kilometer complex includes a 29.6-kilometer main bridge with 6 lanes, 3 per direction, designed for 100 kilometers per hour. A 6.7-kilometer undersea tunnel, the world's longest submerged tunnel for vehicles. 2 artificial islands, hiding the tunnel, easing tunnel-to-bridge transitions. The tunnel sits 40 meters below the sea, allowing 300,000-ton ships to pass. Tunnel segment alignment precision, less than 5 millimeters, like Lego under the ocean. The structure withstands magnitude 8 earthquakes, category 16 typhoons, 200 kilometers per hour winds, and collisions with megaships. A major challenge was the seabed's soft, shifting mud. Engineers used stabilized composite seabed foundations with piles over 100 meters deep, dynamic adjustment systems to absorb tremors and redistribute loads during disasters, Sika additive corrosion-resistant concrete for a 120-year lifespan, 500,000 cubic meters of custom concrete for the submerged tunnel with near-zero error. Over 1,400 firms from Arup and AECOM to local contractors joined the project, compared to New York's LaGuardia Airport, where a 10-year upgrade, 2013 to 2022, cost $8 billion. HZMB started in 2009 and operational by 2018 took 9 years, but its infrastructure scale, technical complexity, and developmental impact far surpass. In the U.S., envisioning a sea-crossing, multi-jurisdiction transport project like HZMB is tough. Delays from regulations, protests, or budgets are likely. HZMB links 3 cities: Hong Kong, former British colony; Macau, former Portuguese colony; and Zhuhai, mainland Chinese city, representing distinct political economic systems. This isn't just geographic, but symbolic regional integration. It's the backbone of the Greater Bay Area, China's bid to rival Silicon Valley as a rapidly growing regional innovation hub. The bridge turns 3 disparate cities into a 1-hour living zone, cutting travel time, expanding labor markets, and boosting logistics and tourism. HZMB doesn't just tie Hong Kong to the mainland, it connects China to a 21st century growth model, focused, fast, and strategically integrated. A key question arises with each Chinese megaproject. Why can they build so fast? The answer isn't just engineering, it's systemic execution. In many nations, especially developed economies, infrastructure faces hurdles, lengthy approvals, local disputes, and multi-level government conflicts. Even a bridge or rail segment can take decades to navigate legislation, impact assessments, and funding. China operates on a centralized, synchronized model, from state planning to capital allocation, engineer coordination, and tech deployment. Projects like Baihetan or HZMB aren't just engineering, they're the result of thousands of firms, research institutes, and crews working as one organism. This structural difference drives organizational capacity and speed. But these bridges, railways, and airports aren't just for domestic flow. They're a new development language, where infrastructure isn't just concrete and steel, but a long-term strategy to upgrade growth models. China isn't building only for itself. It's exporting a comprehensive development model worldwide, from Asia to Africa to the Middle East, through ports, transnational railways, and clean energy corridors. This isn't about global influence. It's about executing a model, offering developing nations tech, engineering, and integrated management systems once exclusive to developed countries. Nicknamed infrastructure maniac globally, China keeps pushing megaprojects, not to compete, but to offer a new choice for a world seeking breakthroughs. From Baihetan to Daxing, Sichuan-Tibet Railway to HZMB, these projects don't just connect lands, they expand what infrastructure can achieve. Looking at China's 5 completed projects, from Himalayan railways and bridges taller than the Eiffel Tower, to underground mega hydropower, starfish-shaped airports, and the planet's longest sea bridge, we're not just seeing engineering feats. In the past, power came from natural resources, military budgets, or market size. In the 21st century, power may stem from infrastructure, defining connectivity, recovery speed, and global reach. China has made infrastructure its long-term growth foundation. Beyond its borders, it's exporting this model globally, offering a full ecosystem, engineering, tech, and large-scale project management expertise. While infrastructure debates continue globally, China is demonstrating what synchronized planning and scale can achieve, from Himalayan railways to undersea tunnels and mountain-powered energy. Of these 5 projects, what amazes you most? The construction speed, the engineering tech, or the long-term vision behind each brick? Which nation do you think will lead infrastructure in the next decade, and why? Drop your thoughts below. We'd love to hear. If you find analyses like this valuable, don't forget to like, subscribe, and hit the bell to catch Top 10 Discoveries Official's next videos. Top 10 Discoveries Official will return with more stunning breakthroughs, monumental projects, and untold stories from around the world. Goodbye and see you next time.